Hi, this is Josh Bridges, and I am here at AGU 2019 presenting some of the work for my PhD thesis. The general idea is that we are studying the Northern Hemisphere glaciation, intensification, and onset between 3.6 and 2.7 million years ago. We are doing this because we believe that the intensification was brought on by a drawdown of CO2 due to iron fertilization sourced from Asian dust. To this end, we examined the magnetic parameters of both Site 1208 and Site 885-886 in the North Pacific. Here I have compiled the magnetic parameters that I have tested for both sites. As you can see from Site 1208, where I've labeled both the supposed onset and intensification event, Site 1208 seems to better record both the onset due to the spikes just following this line and the intensification due to the spikes we see within the shaded region. 885-886, on the other hand, as of this moment, does not appear to record either the onset or the intensification, and in fact, the values seem to stay pretty constant throughout the entire core. We also noted that Site 1208 is better at recording the glacial to interglacial variations, at least through the late Pliocene and early Pleistocene, whereas 885-886 can only do so through the late Pliocene. Once we hit the early Pliocene, about 2.7, where the intensification is supposed to have started, it no longer is able to record those variations. We then compared some of our magnetic parameters with past data, and we also show the exact same results that they do. We see pretty steady results going all the way up until 2.9, 2.8, and again after 2.8 through 2.7 and upwards, suggesting that neither the onset nor the intensification is being recorded at 885-886 currently. We performed a quick mineralogical examination to test the difference between magnetite, which is considered both a terrestrial and marine-sourced mineral, and hematite, which is considered to be a purely hematite mineral, and found that if you judge the gap between the two magnetization levels, Site 1208 seems to record a greater input of hematite and thus dust input, as opposed to 885-886, where the two values seem to track each other almost consistently. Finally, we developed a dust flux proxy based on our HIRM values for both 1208 and 885-886 and compared them to past dust flux records for these two sites. While 1208 seems to track and record the exact same magnitude of past dust fluxes for 1208, our HIRM flux for 885-886, while it tracks the pattern, lacks the same intensity as the ray record for this site. All in all, we believe that Site 1208 is more proximal to the Asian dust sources and thus is better to record these paleoclimatic events. Both stages are able to record the glacial to interglacial variations to some variable degrees. Our conformity of 885-886 data suggests that no variations took place across these two events of interest. The dominant mineralogy is clearly magnetite with a secondary hard coercivity component called hematite. Our HRM flux is able to track past changes in flux when compared to other records, and this suggests its usefulness as a future dust proxy. And because of its lack of comparison with the past Rayer records at 885-886, that these records may not faithfully record the dust records as previously thought.